Okay, so remember there are kind of three principles to a heat of formation reaction. First, has to be just made up of elements. Secondly, those elements have to be in their standard state. Thirdly, you only can make one product, period. Like, has to be a one understood in front of the product. So let's start at the elements. We look at this first one. Yes, that is an element. That's an element. Now we have a compound. That will not count. This one is ruled out. Element, 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 element. So far, so good. Now we need to check their phases. Hydrogen is a gas. And if you're not sure, I wrote it down here. You probably already knew hydrogen and helium were gases. And you probably could guess that nitrogen, oxygen were gases. The other ones are gases are fluorine, chlorine, and then all of the noble gases. All right, so let's keep going. At the top, hydrogen is a gas. Sodium is a solid. The rest of the chart is solid, except for the two exceptions are bromine and mercury. Those are our only liquids. The most of the chart is solid, so assume solid. And then iron, you know that's a solid. Hydrogen's a gas, oxygen's gas, hydrogen, and oxygen is not a liquid, so this one's ruled out. Now we're going to look at the product side, and we need to make sure there's an understood 1. And you'll notice that there's a 2 here, so that rules this out. So this reaction here is the only one that's a heat of formation reaction. I wanted to show you this too. C2H4O4N6. If you wanted to make that a heat of formation reaction, you would need to have carbon plus hydrogen, that's diatomic, plus oxygen, which is diatomic, plus nitrogen, which is diatomic. And you'd balance it all out, is what you'd probably have to do. But just wanted to show you like everything, and that's a solid, that's a gas, and a gas.